Hello all. So today we will be dealing with numericals of alkalinity. Before proceeding towards how to solve them, I am just explaining you the process of titration in a summarized way. First of all, we take the given water sample for which we have to analyze what is the concentration of the alkalinity and what type of alkalinity is present in the water sample. Okay, the volume of the sample taken can vary from 5 ml to 200 ml to 500 ml. Any of the data can be given in the numerical. It can be 10 ml, it can be 25 ml, it can be 50 ml, and so on. So this sample water is to be taken in the conical flask, and after adding the water sample we add 1 drop of phenolphthalein indicated in the same conical flask. Okay, and it should not be more than 1 drop. Let it be that I am taking 500 ml sample, then also I will be taking only 1 drop, right? Now the two conditions can appear. Either the sample will do not give any of the coloration with respect to phenolphthalein. It means our case is P equal to 0. It means the sample has not given any coloration with respect to the phenolphthalein indicator, and when we will be discussing the cases, then I will again explain you how P is equal to 0, right? So now we will note down the concept as V1 ml consumption of acid here will be 0, as no pink color comes up and we don't have to add any of the acid in this particular solution, right? Now when pink color appears, let it be that the second condition is that after addition of phenolphthalein indicator we got pink color, right? So what we have to do, we have to neutralize this sample water with respect to acid. Now in the laboratory, either of the acid can be taken given HCl or H2SO4 of a particular strength, right? So after addition of 1 drops of acid, we have to come to an endpoint where the pink color totally disappears from the solution. Whenever this pink color disappears, then we have to stop the titration and we have to note the consumption of acid till methyl orange and till phenolphthalein endpoint as V1 ml of acid consumed till phenolphthalein endpoint. Now what happens? Either of the condition, the first or the second, right? We can continue this titration in the same conical flask. I am again explaining you. Here we have taken a sample of water, we have added phenolphthalein indicator, and if one first condition no color appears, then we can actually add methyl orange indicator in the same conical flask. If pink color appears, then we will titrate. We will note down the endpoint of the discoloration of the phenolphthalein color to colorless, and then in the same conical flask we are continuing the titration by adding methyl orange indicator 1 drop. Now what happens after that? A yellow color appears due to the addition of methyl orange. Now we will titrate this yellow color solution till we get again the pink color. Okay, this will be V2 ml of acid consumption till methyl orange endpoint. Okay, now what happens if we are adding acid from the burette? If the sample is containing hydroxyl ion, the acid H positive ion will neutralize this OH negative ions and forms water. If the carbonate ion is present, it will be neutralized to half carbonate ions because it will be forming bicarbonate ion and producing an alkalinity which is due to bicarbonate ion. Now either of the step, half carbonate ion neutralized from the this step or separate bicarbonate ions are present in the water sample, it will be neutralized by H positive ions which are present in the acid, and it will form bicarbonate ion, means H2CO3, carbonic acid. Okay, so this is the neutralization reactions for phenolphthalein and methyl orange indicators. Now, while solving the numericals, what we have to note down specifically: the sample volume, what is given, what amount of water is to be analyzed, the strength of the acid given, the N by 20, N by 25, N by 50, etc. What is the V1 ml of consumption till phenolphthalein endpoint, and what is the V2 ml consumption till methyl orange endpoint. If these four values are identified in a particular numerical, half of the things get resolved there itself. Now, what has to be emphasized while solving the numerical of alkalinity? There is no tedious procedure, but the only thing which we have to note down is these things. There can be lot of manipulation given in the language of numerical where we can be twisted around. The language can specify that the titration was done separate. It means water sample is taken, phenolphthalein indicator has been added up, pink color appears, and the acid consumption in means the total acid consumption till phenolphthalein endpoint is 5 ml. This sample is thrown off, and then another sample has been taken, methyl orange is added, and yellow color turns pink at 10 ml when the burette reading is 10 ml. It means the titration was separate. Let it be a second condition is that a titration is continued. It means the water sample is being taken and phenolphthalein indicator added. The total acid consumption is 5 ml. A language will be written up and total volume consumed till methyl orange endpoint is 10 ml. It means first of all at V1 ml the burette reading was 5 ml, and when the methyl orange yellow color turns to pink color, the burette was showing 10 ml volume. So separate volume has been noted down, P for 5 ml and M 10 ml. The titration was continued. Here it is written that at the phenolphthalein endpoint 5 ml consumed and another 10 ml has been consumed till methyl orange. Another, it means more addition of more 10 ml acid was added up. So it will be 5 ml plus 10 ml for methyl orange, and it will be 15 ml, which is the total acid consumption till methyl orange endpoint. It means when we are titrating with respect to methyl orange, the burette reading was shown up as 15 ml. The fourth condition can be a separate titration has been done, and it has been mentioned that the P is not giving any of the coloration with respect to phenolphthalein, and the sample was thrown off, and with respect to methyl orange indicator, the total acid consumption was 10 ml. The fifth condition can be titration was continued. No coloration with respect to phenolphthalein came up, but the total acid consumption till methyl orange endpoint is 10 ml. Okay, so there is a lot of combination and twist and turns which is related to the particular language of how the titration has been proceeded, right, and which has to be really given emphasis while noting this four values with respect to solving the numericals, right. I'm just giving you one example, right. For example, it's been given that you have taken a 50 ml sample volume and the HCl strength was N by 50. The P value, the endpoint of P V1 volume of acid consumed till phenolphthalein endpoint is 5 ml, and another 10 ml was consumed till methyl orange endpoint. It means 5 plus 10, 15 ml was consumed till methyl orange endpoint. Now solving the numericals, it's really easy. N1 V1 equal to N2 V2. This is the acid side, this is the phenolphthalein side. N1 means acid normality, which is given as 1 by 50. Volume consumed of acid till phenolphthalein endpoint is 5 ml. So it will be 5. N2 we have to evaluate, and the 50 is the amount of sample taken. Now here we will be solving. N2 is equal to 5 by 50 into 50 is equal to 5 by 2500. You can solve this value, but eventually it will be cut down. So it will be better that you keep the value as it is for solving the rest part. Now the strength formula in gram per liter is normality into equivalent weight. But as with respect to water, all the things are calculated in ppm and mg per liter or CaCO3 equivalents. We will be multiplying with respect to 1000 to convert it in mg per liter. So this will be 5 by 2500 from the above step, and 50 is the equivalent weight of CaCO3, and 1000 is the factor for converting in mg per liter. So when we are calculating this whole, the concentration of P will be 10 ppm, which is coming up. So we will be telling that strength of P is 10 ppm. In a similar fashion, we will be solving with respect to methyl orange acid and methyl orange endpoint. Now we don't have to write again and again all the things 1 by 50 into 15 into N2 into 50. We can solve this step in this manner as in previous step. Here the consumption of total acid was 5, but in methyl orange it is 5 plus 10, and the same thing 50 by 50 will come as it is. So here it will be 15 by 2500, and N is the normality unit of N2. In a similar way, strength of M is 15 by 2500 into 50 equivalent weight of CaCO3 into 1000. So the total strength at M is 30 ppm. 10 ppm with respect to phenolphthalein, M with respect to 30, right? So after this, what we will be doing, we will be analyzing what type of case is present in our water sample. So we will be evaluating this from the 5 cases which are established for the alkalinity. P equal to 0 means the water sample is not showing any coloration with respect to phenolphthalein. No pink color appears, and the water is contaminated through bicarbonate ion, and the total concentration of the bicarbonate ion in the water sample will be equal to M concentration. If the sample is showing P equal to M value, it means the water sample is contaminated through hydroxyl ion, and the concentration of hydroxyl will be M. In a similar way, P is equal to half M. If it comes up, it shows that the contamination is through carbonate ion, and it will be either M or 2P value. P is less than half M. It means the water sample is having carbonate ion and bicarbonate ion. The concentration of carbonate in the water sample will be 2P, and bicarbonate ion concentration will be M minus 2P. P is greater than half M. It means hydroxyl ion is present in the water sample, and parallelly carbonate ion concentration is present, and the concentration of hydroxyl ion will be 2P minus M, while carbonate ion will be 2M minus P, right? So here in this sample, as we are getting these two values, 10 ppm for P and 30 ppm for M. If we divide by 2, it will be 15 ppm. So obviously we are getting that 10 is less than 15 ppm. So the water sample is contaminated with carbonate ion and the bicarbonate ion as per the tabulation. So the concentration of carbonate ion will be 2P. It means 2 into 10, and 20 ppm, and the bicarbonate ion will be M minus 2p, 30 minus 20 is equal to 10 ppm. So in this manner, we can solve the alkalinity numericals very easily. I will be posting another example soon. Hope this is very much clear. Do let me know if any other concept is needed by you. Okay, thanks a lot.